So a particle is projected at a velocity of 25 meters per second at an angle of 30 degrees. So remember with these questions, you've got to set out your equations first of all. So in the horizontal direction, there's no acceleration. The initial velocity there in the horizontal direction will be 25 cos 30, yeah? Because remember, you need the component here, okay, which will be contain the angle there, so that'll be cos. Now, cos 30 is quite nice, so you could use a calculator and you get 12.5 root 3, okay. In the vertical direction, well, the acceleration is going to be minus 9.8, because remember now we take it upwards as positive, yeah. There's my positive y-axis here, and the initial velocity in the y direction, well, it'll be that component, 25 sine 30, which will just be 12.5 on your calculator. So then if we use v equals u plus at, the general velocity vx will be 12.5 root 3, which is equation 1. General velocity vy will be u minus then 9.8t, because it'll be plus at, so it'll be minus 9.8t. It's equation 2. Using then, to get the general displacement, okay, x then will equal to ut, so it'll be that times t. Acceleration is 0, and then y will be ut, so 12.5t minus then, or plus half at squared, but of course a is minus 9.8, so it'll be half of 9.8 is 4.9, so it'll be minus 4.9t squared. Okay, so it says find the velocity components at 2.5 seconds. Okay, so basically when t is 2.5, 1 implies that the velocity x will be 12.5 root 3. It's always that, isn't it? So that's the horizontal component. Okay. The vertical component you get from equation 2, which would be 12.5 take away 9.8 times 2.5. Okay. So we'll work that out. So I get minus 12. Okay, I think that's right there. Minus 12. Okay, so that will be the vertical component. So we've done that, and then it says hence find the speed and direction of the particle this time. Now, because it's a minus 12, we can get an idea then what direction it's going in. It's on its way down. Okay, quite simply, that's the direction it's going in, roughly, right? You just assume it's there. Okay, that's the direction it's going in. Because it's got horizontal component, velocity component of, what was it, 12.5 root 3. And it's got a vertical component of velocity component of minus 12. Okay, so I'm going to write 12 there, because I know it's going down, because I've got the arrow going down there, so I don't need to write minus. But those are the components. Remember, the velocity determines the direction, so I've got the horizontal, I've got the vertical. So when they want a direction, we need to get an angle, we do. Okay, so we can work out that angle there. But to get the speed, essentially, that's the direction it's going in there. I want the speed it's going in, so I need to work out what v is here. So I need to take the two components, put them together. It's just essentially resolving forces. You just appreciate you've got 12.5 root 3 going that way. And of course, then you've got 12 going that way. Okay, so you've got yourself a triangle to get your v. So all I've done is I've shifted this across here, and you can see my triangle there, and my theta will be there. So to get v, the speed, okay, it'll just be that squared and that squared. It's Pythagoras, isn't it? Okay, and then square root them, of course, once I add them together. Okay, so square that side, square the other side, add them together, and square root. So if I do that, I get 24.8 meters per second. Okay, and to get the angle then, remember, opposite the angle is here, and there's the adjacent, so tan theta, opposite or adjacent to 12 over 12.5 root 3, so you get your theta from there. So I get 28.99 degrees, so basically 30 degrees below the horizontal.